climate and in a sustainable manner. Our guests will provide insight into the multidisciplinary nature of this project from the earliest stages through to the development of highly integrated project details. In addition, they will describe how the new fully glazed roof evolved from an engineering challenge to a key enabler of building's environmental strategy. As the chair of this event, I have the distinct privilege of introducing our guests, Becci Taylor and Andrew Mackay. Becci is a director at Arup with nearly 2 decades of experience in engineering and has worked on several cultural projects with RPBW. She's a mechanical building services engineer and a building physicist, and a leader in cities, residential design, and sustainability. Becci is a multidisciplinary design integrator and an industry expert, working to deliver development that improves the quality of life and drives environmental sustainability. Andrew is an associate in the buildings team at Arup and works across various building typologies and scales. He led the delivery of GES-2 through scheme design stage and has closely followed the project on site as it approaches an opening date towards the end of this year. As they take us through this complex but really exciting building project, please pop your questions in the Q&A box window. And as time permits, we have about 15 minutes towards the end for them to answer your questions. They will do so after their presentation. I now hand over to Becci as she starts our presentation. Over to you, Becci.
Sorry, Becci, you're on mute.
Great start. Okay, so hi everyone. Today we're going to talk about the GES-2 project, as Dola just introduced, for the VAC Foundation. The VAC Foundation was established by the Russian billionaire Leonid Mikhelson and its director Teresa Mavica. It has exhibition, publishing, performative and learning programs, as well as its own art collection, and GES-2 will be its Moscow home. So the site is a disused power station built in 1907, located on the Bolotnaya embankment in the center of Moscow. And our challenge was to make this into a major cultural venue containing 40,000 square meters of galleries, performance, restaurant, office, and artist studios. So as Dola explained, Renzo Piano Building Workshop asked Arup to lead the concept design of sustainability, environmental design, facade engineering, lighting, daylighting, and acoustics, as well as specifying some of the more detailed complex elements of the building. And we worked alongside the Russian team of Apex architects and Metropolis engineers. Because our involvement was actually not from day one at the beginning of the project, many of the concepts already existed before we got involved, and this impacted how we worked. As one of our clients was a major shareholder of the Russian gas company Novatek, it was particularly important to him to incorporate sustainability in a really visible way, which then interestingly set up a narrative about transforming an old coal power station, as you can see up here, into something representing the future of energy. So a key architectural concept that already existed from Renzo Piano Building Workshop was to take off the existing roof of the power station and replace it with glass to form a cathedral of light. And the brief was to be able to put art everywhere. Much contemporary artwork is sensitive to environmental conditions and needs a controlled environment to conserve it with constant temperature and humidity and limited light exposure. So this creates a real challenge. And of course, the building's in Moscow, which has an extreme climate with winters that get down to -25 degrees C. So today I'm going to focus on the broad early stage sustainability and environmental concepts in development in response to the site and the key challenges that I've just outlined. I thought it'd be quite interesting to show you the process responding to existing concepts and then working through opportunities to make them into reality. And then I'll hand over to Andy, who will illustrate some of the more detailed multidisciplinary collaboration that made the concepts really work. So as we joined the team, slightly after everything started, we immediately had to do lots of thinking. How do we make this old power station into a sustainable world-class arts and culture venue? Or how do you minimize operational carbon for a contemporary art center in Moscow built out of an old power station with the roof replaced with glass, which wants to be able to put art everywhere? Quite a challenge. And immediately, and after much discussion with Renzo Piano, it was quite clear that the vision of the glass roof was absolutely immovable by both him and the client. So we sat down with a pen and a paper and a little bit of Excel and really thought about what we had here. So in summer, it's quite clear that with a glass roof, the solar gains dominate the design by far. The key is to protect what's inside the building from the sun. How do we deal with the heat from the glass coming from both the sun and the air? Should we ventilate the facade? Can we use the rising heat and the height of the building to help us? We concluded that essentially the envelope of the main building is a climate moderator, but it can't do all the work. So we thought that putting art enclosures within that main envelope was key to the success of the project. We also needed to think closely about heat rejection, how to capture the useful waste summer heat for dehumidification required for gallery conditions, and also for the hot water for the various different uses in the building. And of course, the large roof area with a significant amount of sun allows us to generate quite a lot of power over it. So in winter, the most important thing is how cold it gets. The outside air is the key issue. The conduction from the facade and any air leakage losses really dominate the requirements of the building. So any heat we can trap inside is key. And now we want the envelope to work really, really hard to moderate the climate by containing the heat and the moisture inside it. But condensation and comfort are really critical at the outside of the building, where it's -25 outside sometimes, remember. And also this is even more critical if you want to humidify the air inside to protect the sensitive art. So the heat for the building is a given that it's provided by the city district heating system. So the key really to sustainability here is to use it as efficiently as possible. And again, in the winter, we concluded that art enclosures and an assessment of the wider brief to zone conditions would be key to a truly efficient design. Now, putting art everywhere, this really creates a burden of air conditioning in a building this large, especially with the humidity control that you need and the humidification you require in the very dry Moscow winter. This led us to really discuss with the client about the brief and whether they really wanted this. They wanted to be able to borrow art for borrow other people's contemporary art for shows that would come with a requirement to demonstrate that the environment it was going to be put in would meet the exacting environmental requirements. And it was clear this is going to be really challenging, highly energy intensive, and not in line with the sustainable brief. And also we even had a question if this is really going to be possible in all locations. So we needed to address this and change the brief slightly to apply limits to where it was going to be possible to put art. And the other key issue for art conservation is light. Light, as I said, is key to the architectural concept to provide somewhere bright and really happy for the visitors. But much contemporary art cannot be exposed to high light levels for too long, and certainly not to direct sun, even with these shadows. So daylight admission to art galleries has to be controlled to achieve the conservation requirements. On the other hand, daylight allows us to save electric light energy. Our design for VAC uses LED lights with Bluetooth mesh control technology, which allows individual control of each light so that only the right amount of light is delivered, and it's based on how much daylight is available at any one time. So back to that brief. What we did was develop the concept of a hierarchy of space conditions. The main envelope was a climate moderator, and then there were art boxes inside it, meaning that we could, in most of the space, just provide comfort conditions for people. And then within the art zones, we could control them to much closer conditions. This means that we reduce the amount of area and also potentially the amount of time that we need to control to such energy intensive conditions. So to do this, we defined 3 different space types in terms of light levels, cumulative light exposure, temperature, and relative humidity. The sensitive display type G1 has very low light levels and a very tightly controlled temperature and humidity band. There's an intermediate gallery type, which has daylight and slightly wider conditions. And then the rest of the building can show art, but it must be insensitive. So the facade of this existing building has an awful lot of work to do. It has to reduce energy consumption, provide comfort, prevent condensation. Also, the building was listed, so we had a heritage requirement. It needed to control the sun, to control the daylight, to generate power, and also to hang art on the inside of it. It's a very hard-working facade. And as a result, it became quite a layered system with all of its own challenges that I'll be leaving to Andy to tell you more after this. It's interesting to understand that we actually didn't fully insulate the existing solid walls. This is partly because they're 1 meter thick, which actually gives them U values quite similar to glazing, and they form a relatively small percentage of the whole building. The window and the roof performance really dominate the overall. We couldn't insulate them externally for heritage reasons, and insulating them internally created potential issues with freezing of the existing brick due to the high levels of internal humidity. The large open area has a large range of conditions. You can see the image on the bottom left showing the stratification of the space in the summer. The concept of having art spaces inside this created its own challenges. One interesting one to show you was the potentially large environmental changes at internal doors. And we looked at how much impact this would have on the galleries when doors were used. This analysis allowed us to provide guidance for where you located sensitive artworks, meaning that you didn't have to have additional lobbies. So the chimneys, this is a nice story to give you a sort of flavour of what happens when you come to a project not quite at the beginning. The previous consultant had proposed turbines at the top of wind turbines at the top of the power station chimneys driven by natural ventilation. So the power station chimneys themselves are quite interesting. You can see the original ones made out of brick, and then later steel. And originally Renzo Piano Building Workshop were intending to keep them, but actually they eventually ended up replacing them. So the turbines driven by natural ventilation were definitely not a good idea. Natural ventilation is not great for art conservation or climate control in Moscow, and actually they really weren't going to generate very much power. So the next idea was to put wind turbines at the top of the chimneys. These were quite desirable to the client because they were quite a visible, sustainable technology. But putting a wind turbine at the top of a chimney of an occupied building with a glass roof creates maintenance issues, a risk of injury from blades falling, which is a real problem. And then also they really don't create very much power, so it wasn't a great plan. But these chimneys, as I said, are quite an important part of the architecture, and it was quite important that we tried to make them useful. So in the end, what we did was we used them for air intakes. They take good quality air from outside the polluted area, the polluted air in the center of Moscow. And here they are, the new chimneys. You can see they're really important aesthetically as an icon of the building. And actually they do generate much healthier air. And if you look at the GES-2 Instagram, you can see that they really are quite emblematic of the building. So in summary, for the design, what we tried to do was do things that really actually were sustainable as well as being visible and truly made a difference to the performance of the building. From an already energy efficient baseline, we made approximately a 30% reduction in energy consumption with the measures I've described. Quite difficult to calculate carbon because the district heating supply in Moscow doesn't have that information available. But the biggest step change we made was changing the brief not to have art everywhere, and then improving fabric, capturing reject heat from cooling, and of course the solar power. We are on track to achieve LEED Gold, which in the context of the Russian construction industry in 2016, when we started this project, was quite a radical thing to do. It's quite important to the client to have an internationally recognized standard, a sort of badge for his building. Although again, because we weren't involved from day one, this was trickier to achieve than it would have been if we'd been on that journey right from the start. It's been quite challenging to deliver this because the delivery team were not familiar with it, and there's a language barrier between the lead process and the engineers working on the job to deliver it. So I guess the most positive story about this is how important it's been, because the client is really invested in the outcome and to get this badge for the building. And we remain involved in checking and upholding the sustainability design concepts all the way through to delivery, which means that they actually have to get delivered. And in the end, as well as the 30% energy savings I described, the building is doing pretty well because it saves 55% of the existing fabric. And it's actually added a lot of biodiversity that you can see here to an existing industrial site. There's a whole birch forest being planted. It's also got a large sustainable urban drainage system and rainwater recycling. One of the design concepts that got away that I thought would be quite nice just to show you was we looked at trying to reuse the power station cooling infrastructure, because the building sits between the Moskva River and the Bolotnaya Canal, but this proved impractical to do in its current configuration. Essentially, the water used to run right through the power station. But I thought it'd be just quite nice to share this historic diagram. We did try quite hard. We were quite excited about this concept at one point. So thank you for listening. That was essentially what happened right at the beginning of the project. And now I'll hand over to Andy to show you what happened next. Thank you.
Thanks very much, Becky. I'm Andy Mackay. I also work for Arup in the buildings team, and I led the Arup multidisciplinary team through from scheme stage through project and tender, which are Russian design stages, right through to our start on site. And I'm going to talk to you a little bit about delivering some of those concepts that Becky described, and particularly focused on the creating of the galleries. Becky described the challenges of having the galleries open to the internal atrium of the building and having it all one space. So we created this box in box scheme that Becky described. But as we entered stage 3, essentially, so the project stage, but we got more and more trapped in this difficulty of trying to deliver this detail. It led to lots of challenges. I think number one was really the buildability of it. So we ended up with this 6-layer roof, all trying to do multiple different things, and building that, suspending that below a roof of an existing roof, and then creating a neat interface with the partitions that we're trying to build made that very difficult, especially when we were looking at temporary partitions that could open and shut. The roof itself was working really hard, so we needed to access the bottom of it to get to all of the various different components that live underneath the roof. So making that void in between the two roofs became very difficult. And Renzo Piano Building Workshop also found it very difficult in terms of understanding the aesthetic of how that roof would look and how that would feel, going from the cathedral of light that you saw many pictures of in Becky's presentation, and stepping inside into something that felt much more enclosed. So we really wrestled with these details for quite a while, and at the same time we were working quite hard in our facades team with the local engineers in Moscow, who were leading the facade cleaning and access strategy. And as you can imagine, roof clearance of snow is a really big challenge in Moscow. It doesn't snow an awful lot. It snows probably 5 or 6 times a year usually, but it snows very heavily when it does snow, and then because it's so cold, it doesn't go anywhere. So you have to design very carefully to work out how you can get snow off your roof, or you have to design your roof to allow it to stay on there. And neither of those were particularly easy to achieve. So we were exploring all these different ways of getting people up onto the roof, and we were finding it very difficult on top of a glass roof to make it safe, to avoid them damaging the roof, but also we wanted that snow to be cleared off very quickly, because the roof is such a key enabler of our building. With the roof covered in snow, it's not bringing light into the building anymore. Which is a real central part of the philosophy of the building, that cathedral of light. People come in from Moscow and from the dark, cold spaces that generally exist, and really enjoy the warmth and daylight. So that element got away when the roof is covered in snow, and also the roof is covered in photovoltaic cells to generate energy, and as soon as they're covered in snow, they're not generating any energy either. So we needed to get rid of snow, and we just didn't really know how to do it. So having wrestled with that challenge for a little while, it was time for the Renzo Piano annual summer break. So they shut the office in August, similar to a lot of places in Europe. And Renzo gets tired of his life by the sea in Liguria and heads off to the Italian Alps to reflect. And when he came back, he had decided that the Madonna had spoken to him, and actually the compromise of the box and box within the Cathedral of Light was a step too far, and that actually it was very, very important to the concept of the building that continuity of that glazed roof continued inside the galleries. So when the Arup team heard about this, there was a bit of a sucking of teeth, and oh, I'm not sure about this. This is going to be very hard to achieve now. But at the same time, it unlocked a lot of the challenges that we'd been struggling with, and that we'd creating that secondary roof. So we still needed to keep that compartmentation. It was still a separate space from the rest of the atrium, but those partitions wanted to go all the way up to the roof, and so you can stand inside the gallery and look up at that glazed roof and see everything working, and see that heritage structure of the roof. So the roof was working hard before, and now it's going to have to work even harder. We're going to have to maintain gallery conditions within the space, so it's going to have to be that controlled temperature and humidity. The light is very important, so the quality of the light, the strength of it, the color of it is going to have to be perfect, and it's going to have to be diffused all by the glass roof. And on top of that, there's also sub challenges within it. So cold surfaces create drafts. As anyone who sat next to a cold window knows, and drafts are also very challenging in art galleries. It's very important to minimize the amount of drafts to maintain that still air that allows a wide variety of particularly paintings to be stored. So we had all of these challenges, and they all belong to different people. So we had multiple disciplines from Arup working on the project. We had our lighting designers, our building physicists, our facade engineers, our service engineers. And we also were working with the Metropolis equivalents, and we were based in Moscow, and we were working with Renzo Piano to try and get the architecture to work. And we were all overlapping and trying to get our drivers to be met and achieve our outcomes that we needed from this gallery space. But what worked very well in the project was this approach of total design that the whole design team brought into. So I think it helped that Arup were delivering a lot of the disciplines, but Renzo Piano were very engaged in this as well, and really wanted to bring everyone together to try and solve all of these problems together. So a real total design approach to the architecture. So we got the pens out, and we looked at how we can get this roof to work. And what was really important was that shared understanding that we needed. So all of those multiple disciplines, when they needed to talk to each other, we needed to work together to understand what each person, each discipline needed to get to in terms of the design. And then when we had reached that shared understanding, it was time to go back to first principles and really analyze exactly what each component needed to do, and not just what it needed to do for you, but what it needed to do for the other disciplines. And so looking at all of those elements of the roof holistically, and then iteratively working through different options and seeing how each of those options affected everybody in the design team. So we used a variety of different software tools and analysis tools that we all then had to share back into a common environment. But really, it was all about that buying into that strategy of everyone having to work together to get this to work. So it became, as we went through this process, it became clearer and clearer that all of these connected drivers that originally gave us this sucking of teeth of complexity actually also offer these opportunities, in that so many of these requirements also are deliver solutions that have other functions. So the synergy between these different requirements and the different solutions actually allowed a simplification and a reduction of the components that we needed to get that continuous whole. I'm going to talk to you about a couple of specific examples of where that was particularly true. And apologies, that I'm a services engineer, so these are a little bit building physics focused, but I think they're quite interesting and quite reflective of the whole process in general. So first one is the scrim. So the scrim is a bit of jargon, I think, but what the scrim was there for is it's essentially it was a Willem screen that was put up against the roof, and its original function was really to diffuse the amount of daylight that was coming through, partly to reduce its intensity, but also because of the photovoltaic cells that were on the outside of the roof on that top layer. There's a lot of patterning on the floor of the gallery, which is visually disturbing and also risks damage to the art in terms of a variation of intensity across the art. So the velour screen diffused that and reduced the amount of patterning we had. But as we looked into that component, we realized actually this is going to have a beneficial effect on the surface temperature. So when you're standing on the floor of the gallery looking up at the roof, you're going to feel cold if there's nothing there, because the surface temperature of that roof is going to be so cold it's going to create a temperature asymmetry and create discomfort. But the velour screen balances that and reduces that, or rather increases that surface temperature. But something that also that came out of that that analysis was realized that we were having these big problems with drafts that I mentioned earlier. So we had the cold surface up on the roof and warm surface at the bottom of the gallery, which was creating this circulation. So we had a continuous circulation of air, which at a velocity that was too high for us to be able to be confident that the art would be protected. And it was the air was running down the back of the scrim, but what we realized actually is it's coming into quite a tight channel, and if we could just reduce the velocity of the air physically while it was going through that channel, we would be able to create enough drag that would break up that circulation pattern. So we looked at the structure of the scrim, and as you can see in that top right diagram, we expressed the fins that were holding the scrim, the velour, onto the screen. And by creating enough resistance to that airflow, we broke up the air circulation patterns. And you can see on the bottom right diagram that the air velocity was much reduced, and we got to a point where the art conditions were satisfied. Another example was our trace heating. So as you can imagine, we needed to put an awful lot of heat into this building to keep it comfortable. And one of the key ways that we delivered heating was to the roof, and the main reason we were doing that again was to reduce those drafts. So we looked at ways of integrating trace heating. So it's like a strip of electrical cable that has a conductive sheath around it that allows heating to travel along the length of the cable. And so we introduced that into the structure of the roof, which heated up the roof to the point where the surface temperature of that wasn't creating those issues with the drafts. It was we were a bit concerned about energy penalty at this point, but what we realized was that actually it was only required at very extreme conditions. So I think we got to the point where when it was below -20, it was time to switch on the trace heating, but the majority of the occupied hours of the building, that the trace heating didn't need to operate. So the energy penalty was slightly lessened. But when we looked at the effects of the trace heating, it had the benefit of increasing that surface temperature and improving comfort, but actually it had a real benefit in unlocking the facade, the roof design, in that the thermal bridging detail of the roof was extremely challenging. We were looking at quite sophisticated roof systems to get that to work, because as Becci mentioned earlier, condensation is a big risk when you have a a temperate gallery, and then you have a very, very cold outside air temperature. So the thermal bridges had to be perfectly designed to avoid any risk of condensation. And the systems we were looking at weren't doing the job for us until we looked at this trace heating and realized that actually when we analyze the effect of the trace heating is providing the benefit to me as a services designer, because I'm able to make sure that the people in the gallery below are comfortable, but also it's lifting the surface temperature of the inside of the roof structure enough that it's also minimizing condensation in those extreme winter conditions. And then I want to talk to you about the photovoltaics as well. So I think we've mentioned them a couple of times, but we've not really talked in detail. So the photovoltaics had a really key function to us in that obviously they were generating energy, and it was a really nice story for the building in terms of moving away from the old fossil fuel power station through to a new renewable future-looking power station, if you like, that was generating its own energy. And so that was exciting to the building concept. But actually, it was also fundamentally important to us because the photovoltaic cells actually provide shading as well. So it doesn't, when you saw the pictures that Becci showed, it still feels extremely light in that gallery, in that central atrium, in the nave we call it. But actually the roof is covered by 90% photovoltaics, but because the amount of glass that still surrounds that allows enough daylight into the space to really feel extremely well lit. But that 90% reduction meant that in light was really important to make it less visually uncomfortable, but also significantly reduced solar gain. So we were able to keep the spaces more comfortable in the summer. But I want to go back to that snow problem that I kind of teased you with earlier, but didn't really talk about anymore. So we were still wrestling with this problem until we realized actually photovoltaics they're just one element of an electrical system. And actually, if you instead of using them to generate electricity, you can also use them to emit heat by reversing the current in the photovoltaic cell and sending energy back out to the photovoltaics. So we thought, well, when we're covered in snow, we're not generating any energy, are we? So why don't we send energy back up to the photovoltaics and melt the snow? And that sounds extremely wasteful, I know. But again, to go back to that, the climate of Moscow, it doesn't snow very often. So once you've melted the snow that's fallen for that month, it's going to stay dry after that, and so you can go back to generating energy. And of course the benefit of having the natural daylight into the space is also an energy benefit as well. So there was an overall, even though we're using that electrical energy to melt that snow, there was an overall net energy benefit, and also it meant that it was a much safer and easier way to quickly get rid of the snow from the building rather than having to rely on people going up there 5 or 6 times a year. So we went through this with the roof designer, with various different PV designers, and then of course we also had to, being this is a highly visible roof, we had to be very, very careful where all the cables went, and cable design is actually quite important as well in terms of minimizing the amount of cable run and energy loss that happens through that. So we worked very hard with the Renzo Piano to coordinate even those cables. So when Becci says we delivered the concept design principles, I think there was elements where we went a lot further than that, and I think the benefit was really felt by the time we got to the end of the roof design process, and we really had this one coherent roof system that worked consistently for the galleries, for the nave, for that central atrium, and throughout the building, and delivered everything that all of those different disciplines needed it to do. And I think there's 2 key ways that we really that delivered this. And the first method is something that we're all getting better and better at, is our use of technology in design. So we share 3D models, and we work in this 3D environment. But one thing that was really important to us was the ability to use that 3D environment to use our analysis. So for example, we took Renzo Piano's Rhino model of the building, and we imported that into our building physics software that was then used for finite element analysis by the facade engineer to check the surface temperatures of different elements and different thermal bridges, which we then fed back into our CFD, our computational fluid dynamic model, which allowed us to understand how the air flows within the space. And then we could iterate that back through to say, actually, it doesn't quite work like that. We need to, so for example, add more depth to the fins that are on the scrims, and we could then feed that back round, and it worked very well, all working in that data environment. So that was one element, but actually I think that what was most successful really was the human connection element on this project, and that it was a very diverse project team in terms of where people were based. So obviously Arup, Becci and I are based in London, and then Renzo Piano, we were working with the Paris office of Renzo Piano, and then we had our specialists in Moscow. We also had a structural engineer from Italy, but it was very important to us that we could all come together and understand those different drivers and get through that total design process. And this is a photo from this is in Renzo Piano's basement in Paris. You can see a bit of some samples from the roof PV panels in the background there, and you can see lots of different sketches and diagrams and lots of people working very hard. But I think what's quite interesting is that actually there isn't a single person from Renzo Piano in this photo. They're in the room, they're there, but what was really successful is that they enabled all the people to come together and work together to understand and create this total design philosophy. So you've got an Italian structural engineer talking to a Russian services engineer about a detail, while you've got an Arab acoustic engineer earwigging a little bit in the background, while a Russian architect looks on, and everyone's working together and understanding and drawing and sketching, and that working in that one space was very successful for us. So just to finish off, here are some photos from on site, so you can see some of the progress that we're at. So it's been on site for 3 years now, and well, more if you include the enabling works, and we're very close now, and we're very excited to be able to go and visit this building and really enjoy it in the way that it's meant to be enjoyed as a public space for the whole world, really. So yeah, we're looking forward to it opening in 2021, and hopefully we'll live in a world that will allow us to go and visit it. So that's everything from Becci and I, and I think we're looking forward to answering some of your questions now.
Thank you so much for that amazing, exciting project. I'm quite jealous. We have one question that's come through for you. And Andrew, if you will, it asks, what happens to the water from the melted snow, and could it be put to use?
It's so the melted snow, it's a slightly exaggerated rainwater drainage system on the roof to cope with snow and melting ice, essentially. It's a very resilient system, but that all gets collected in the same way rainwater does, and it's then incorporated into our rainwater harvesting system and used for irrigation and other non-potable uses over the site.
Oh, okay. And that's the only question that has come through. But for me, I found it quite intriguing when you were talking about the photovoltaic panels and how you were able to spin that, not just generating energy, but using it to melt the snow. That was actually quite remarkable. If there are more questions, please pop them in the Q&A box, not in the chat box. But for now, there are no questions. And I think for me, from my perspective, what this project just shows is that there is always value in what we'll call old assets. And you were able to bring that out. Another question has just come through. And it says, what were the reasons for you not being involved from the outset of the project? Let's take that one first. There's another one coming through. They're coming quite fast now. So Andrew, if you can answer that question, what were the reasons for you not being involved from the outset of the project?
Sure, thank you. So I think there was a very strong original concept that the client came to Renzo Piano with, that was embedded with their own input from their own specialists and their own conversations. And I think Renzo Piano were keen to explore that at the beginning. And then in terms of how we got involved and why we got involved, I think that's about our existing relationship with Renzo. Isn't that right, Becci?
Yeah. Yeah, exactly. I mean, there was a different sustainability consultant on the project before we were involved. The reasons for them leaving, I guess they just weren't as good as we were going to be. It was in 2016. My memory is a little bit hazy. But yeah, the main reason for us getting involved after the previous consultant's involvement was because Renzo Piano Building Workshop really wanted to make sure that we were challenging the opportunities of the site based on our long-standing relationship. And I think that just had to kind of come at the right time. I mean, normally we would on this type of project be involved right from the outset, and then we can definitely realize a much greater range of opportunities by developing the concepts together.
Lovely. Thank you so much for that. And then there's a follow-on question on the back of that. It said, how could this change in the future?
Well, I think, I mean, yeah, that's essentially, that's always the ideal. And actually, like, we'd like to be involved as engineers right from kind of strategic briefing stage, because if we think about what the building should be before we start designing it, then we can make a difference. And actually, the story we've just told is the perfect example of this. So if we'd been involved at strategic briefing stage, knowing that you wanted to turn a power station into an art gallery, the first thing we would have said was, well, you're going to need to build enclosures inside it. And that would have been something that we'd have been thinking about right from the beginning. Whereas what actually happened in this process was we were constantly trying to make it work. And the design process would have simply been more efficient.
Fantastic. Thank you so much. And to those of you that are participating, just to let you know that the slides can be available after the webinar, and it can be circulated. So that just so you know that you can access the slides that you've seen today. I have another question for you, Becci, for you and also Andrew, but I'll pose it to Becci first. It says, thanks for the fantastic presentation, both speakers. Was consideration given to the future climate projections? As I understand, Russia will see shorter winters with potentially higher intensity snowstorms. Was this considered in the design?
Yes, we always make kind of future climate years part of our design criteria. We were working quite closely as well with our Russian partners, so that would all be codified. But yeah, we always on every design look at the future climate projections.
Great, thank you so much for that. Another question here says, were there any challenges about this project being in a foreign country? I think you alluded to some of that as well, other than the language barrier, I'm guessing.
There certainly.
Okay.
So I think the biggest thing for us was we as Arup in London, we had an office in Moscow, and so we knew the local market a little bit, but actually what was really needed was somebody on the client side who really understood the approval systems that for getting through, so for example, the fire engineering approach, which is very much a different process in Russia and in Moscow than it was here. So it was very difficult for us to understand in the specific context of our project exactly how that was going to happen. So it was very important to us to have so Metropolis, who we mentioned a couple of times, as a local engineer, and Apex as a local architect who helped along with that. And then I think the one that we've really struggled with, I suppose, is the language barrier, but it's for LEED, as Becci mentioned. So LEED only exists in English, really, and certainly not in Russian, and all of your documents need to be submitted in English, which I think is a frustrating and not very inclusive approach to how that works really, but they have such a small market in Russia at the moment that they don't have the experience to be able to translate that. So we had to require all of our documents to be translated into English and then back into Russian, obviously, to be built on site. So it was a bit of a double hand there. And then travel. I mean, Becky, you had some issues with travel, I think.
Yeah, I can. I think just wanted to add before that the reason that we were doing the project out of our London office was because we were working with Renzo Piano's Paris office. And we don't have an office in Paris, but that was the main reason for being located in that place, so that we could work closely with the architect, because that was much more of the interaction at that stage of the project. But yeah, I did basically almost get arrested because I got my passport stolen on the way to a meeting on the airplane. So I couldn't actually get out through Russian immigration. So the language barrier there was quite bad, and I still think I may be blacklisted to go to the opening party. But so that's got a few months to try and figure that out. And of course, I have to be able to travel as well.
Wow, that sounds very scary. Oh my God. We have a couple more questions. So a gentleman asked a question here. We heard in your presentation about how you use 3D models as well as 2D drawings. How did you manage the process of integrating different data sources, and what challenges did you encounter? Andrew, if you can respond.
Yeah, certainly. So we Renzo Piano delivered their building in Revit, as did we, which was very helpful. They had a fantastic model and a fantastic approach to their housekeeping of that model as well. So you can imagine the size of the model and the level of detail that we were putting into it would be phenomenal. So they were really on top of making sure that they had absolute kind of clarity of what was in that model and keeping it as light as possible. And then it was all about the kind of exporting from Revit into other software tools. So that it was generally straightforward, I think, really. We were as MEP, we were modeling in Revit and swapping models backwards and forwards, and that worked very well. And then Renzo Piano's exports, they exported in open format for us for our more sophisticated analysis tools, and everything was fine. We delivered in 2D. So all of our drawings went as 2D, and I think that's based on what they were set up for in Moscow in terms of Metropolis, as well as how it would be delivered on site and the approval process that went through. But the 3D was a really kind of key aspect to how we could get that coordination to work.
Cool. That sounds great. Thank you so much for that. This question is from someone that I think you might know. His name is Adam Fahid.
Hi, Adam.
Hi, Adam.
Hi, Andy and Becky. Love the presentation. It's great to hear from you again. I was wondering if using solar power heating system or air heating system was considered. In terms of PV efficiency, was it monocrystalline PV cells used? Did you explore using newer cells with high efficiency in the market? So if Becky, if you want to respond to that, and then maybe Andrew as well.
Yeah, I can take the first part of the question. I mean, I think solar water heating would have been possible, but ultimately the main thing was that sort of architectural integration with the roof that you saw there. Actually, the hot water that you would need when the sun was out, we were mostly going to be getting from heat rejection from the cooling system. So we were harvesting heat from condensers. Not quite sure what you mean by an air heating system. Perhaps, I mean, the whole building is heated by hot air fundamentally. So I think, yeah, and in terms of the PV cell details, I mean, I think that I'm pretty sure they're monocrystalline, right, Andy?
They are, yeah. So we were I don't know if it was clear from our presentation, but it wasn't a traditional PV panel that you'd see that you'd mount on a roof. It was a building integrated PV approach. Essentially, it's a film that's applied across the laminate glass. So it really just looks like a sheet of glazing with a cable that comes out at the end of it. So it's very easy to integrate that into a roof. So that limited us slightly with the technology that we could use. But it was, so it was monocrystalline that was used in the end.
Thank you so much, Andrew. And to Becci, same from Andrew Adam, it says you mentioned there was a river flowing near the site, and he was wondering if you explored using water source heat pumps.
Yes, we did. Actually, we were quite excited about that for a short time. The building's actually between a river and the canal that goes off the river, and that's because that was the infrastructure was used to cool the power station when it was still being used. We looked very carefully at it, but there simply wasn't enough flow in the water to make it a feasible type of technology. The sort of infrastructure that was used for the power station took water right through the power station between the river and the canal. We tried really hard because it was such a lovely narrative as well as everything else, but it just didn't stack up. And if we had installed something like that, the amount of energy we saved would have ended up being so small, and the capital infrastructure wouldn't have made any sense.
Yeah, thank you so much for that, Becci. To this question, I think this is quite straightforward because I think the answer is yes. It says, did you make use of any old components of the power station?
So we maintained the facade and actually the roof structure as well, which was it was a beautiful, I mean, you probably saw in some of the pictures, a beautiful old roof structure, but very lightweight, which meant that another limitation on the roof that we were trying to put on top of it. Unfortunately, we didn't recycle the chimneys in the end. I think that was more to do with the kind of the condition of them and the safety of actually integrating that into our new roof. But I think, was it 55% of the facade, Becci? The
building, 55% of the building was retained. I mean, all of the solid elements were retained. So I think, yeah, I mean, that was a large percentage of what wasn't retained would have been the roof, if you think about the area of the building. But yeah, as much as possible was retained, and that was required because it was listed. Well, the Russian version of listed.
Absolutely. Thank you so much for that. And Farhang is saying here that maybe he missed it. So can you please let us know how you tested your early stage design ideas about stack ventilation? Andrew, you want to help us with that?
Sure. So with extensive analysis, so you saw maybe some of the images that earlier in the presentation of CFD that we did in the galleries to prove that the gallery worked and the airflow, but we did that throughout the whole building. It was partly driven by us wanting to make sure that people were comfortable enough. I think there was a reluctance from the client's team, certainly, that they thought that maybe we were trying to keep the air temperature in that central nave as cold as possible to maintain energy efficiency. So we thought that 16, 17 degrees would be acceptable, and there was a big pushback from the client on that. But we demonstrated with our CFD analysis that actually would be acceptable because you had such warm surface temperatures from our systems like underfloor heating, and that the activity of the people moving around in that space would keep them comfortable. And then we had to analyze the air temperature and movement in that central space very carefully as well, because again of that condensation risk, and understanding if the air heated up through that stack effect, and we have a very warm surface temperature right up at the roof, is that going to increase the risk of condensation if we've got local humidity sources nearby? So it was all of these elements were extensively analysed to kind of meet that sort of double criteria of energy efficiency, but also functionality.
Super. Thank you so much. And last but not least, this is a question about indoor air quality. So it says here, was indoor air quality and indoor environmental quality considered in the design?
Well, yes. I mean, that's essentially what the the Chimneys were providing in the end. So the sustainability strategy became much more comprehensive once we were involved. So the idea of taking external air from quite a polluted part of Moscow from much higher up enabled us to really have a much better level of air quality and reduce the level of filtration required, which then actually saved energy in itself. And the indoor environmental quality, I mean, that's a broad term, but essentially indoor environmental quality in its broadest sense is fundamental to the design. That is what the design's about. Taking that that solid roof off and replacing it with glass was about providing a place where people really wanted to come and sort of celebrate culture. I think we spent a lot of time on the project worrying about the entrance and security and how you could make it very open to the public while still sort of maintaining the ability to sort of screen people coming in as required given the contents of the building. So yeah, and if you mean indoor environmental quality in terms of air and temperature, then yeah, that was also fundamental to our design.
I think I did promise that I would give a shout out to our Arup lead team, who this week had the really exciting news that we achieved our lead design credits. So we have a lead design certification for the building, which is yes, hugely exciting and a massive achievement. But we achieved all of our air quality credits through lead as well. So we were not only were doing those kind of more big design moves that Becci mentioned about the chimneys, but we're also doing all the kind of the system side stuff with filtration and making sure the ventilation rates were right, and all of those boxes that we needed to tick to get the lead credits.
Super, that sounds amazing. And on behalf of the Institute, I just want to say a huge thank you and congratulations as well for achieving the award for this amazing project. I found it quite fascinating that heritage properties, because I have interest in existing buildings, particularly heritage properties, that we can actually extract new value out of something that looks old and derelict. So thank you so much for sharing that with us. That was actually quite exciting to listen to. And hopefully when we call on you again, you'll be you'll be available to come and share some of your projects with us. On behalf of the Institute, Becci, Andrew, thank you so much. And for every single person that has participated, just so you know, the slides will be available and they'll be circulated to the Institute. Thank you so much, Becci. And thank you, Andrew, for being here.
Thank you.
Thank you, Dela.